This is brought to you by the Alumni Association of PISJ-ES.
Hey guys, today we will be starting with a new topic and a very basic topic of physics that you all should have a very proper hang on. It's called kinematics or kinematics, however you want to pronounce it. Now basically kinematics or kinematics is the study of motion. So it's all about particles that are moving or objects that are moving. Now some of the quantities that you have to familiarize yourself with are, first of all, speed, distance, velocity, acceleration, displacement, and time. So there are 6 quantities that we will use very frequently in these lectures, and you should have a very proper grip on all of these. First of all, let me start with telling you about scalars and vectors. You might have heard of both of these terms. Scalars are quantities that have only the magnitude of importance. For example, distance. Now, if for example, if you tell me that you covered a distance of 85 kilometers, this information would be sufficient for me, and I would understand that okay, you traveled a distance of 85 kilometers, and that's all right. That's completely enough. You do not need anything else. So 85 is the magnitude of distance. For scalars, only the magnitude is of importance. But with a vector, vectors are quantities that have both the magnitude and direction of importance. Now, there are some quantities for which the magnitude and the direction both are of importance. For example, let me talk about velocity. For velocity, if you tell me that you have traveled at a velocity of 4 meters per second, and we know about this unit, meters per second is the unit of velocity. If you travel at a velocity of 4 meters per second, this information would not be sufficient. You will have to tell me that, hey, I traveled at a velocity of 4 meters per second to the right of, for example, a point O. For example, this is a point O, and you traveled to the right of this, or to the left of this, or to east, or to west, or to the north, to northwest, to north, to southwest, southeast, whichever direction, but you will have to specify the direction. Otherwise, this information would not be sufficient. So let's see some of the very regular scalar and vector quantities that we'll be using in this chapter and their counterparts. The scalars, and these are the vectors here. Now, first of all, speed is a scalar quantity. When you're talking about speed, it's just simply the magnitude. You tell me 4 kilometers per hour and that's it. I do not need to know the direction of the 4 kilometers per hour. But when you say my velocity was 4 kilometers per hour, you will have to tell me in which direction exactly. So velocity is a counterpart of speed. It's the same thing, but with an additional direction to it. Similarly, distance is a scalar quantity. If you tell me you traveled a distance of 85 kilometers, yes, that's all cool for me. But if you tell me you traveled a displacement of 85 kilometers, you will need to tell me the direction from a specific point of your displacement. So again, distance and displacement are just the same thing, but displacement has an additional direction to it that the distance lacks. Okay, so time is a scalar quantity. You don't need a direction for time. However, acceleration is a vector quantity. So whenever you'll be talking about acceleration, you will always tell me that there is a specified direction of your acceleration. So these were some of the examples of scalars and vectors. Let's look at it each one separately. First of all, distance and displacement. You know these are essentially the same things by now. The unit, the SI unit, I mean, would be meters. Okay, but they can be expressed in kilometers and miles and whatever, centimeters and anything. So the unit is meters. Now let me take an example. For example, this is a point O, and you traveled a distance from here to here and till this point. This was your final point, which is P. Now this distance was 10 meters, this was 2 meters, and this was 15 meters. If I ask you the distance you have traveled, that would be, you first went 10 meters, then 2 meters, which is 10 plus 2 plus 15. And you will tell me that you have traveled a distance of 27 meters. However, if I ask you your displacement is not 27 meters. It is simply, since this is 10 meters here, and this is extra 5 meters, so it is simply 5 meters from O to the left or to the west, because this depends on your final and original position. The path taken is not of importance. So even if I take a different route like this, I don't know the readings, I take a different route like this and I reach to this point here, to here, I reach to this point here, and I ask you the displacement, it will again be 5 meters from O to the west. The entire path would not be of importance, only the final direction and the magnitude of the final position from the original position. However, if I ask you about the distance, you will have to add all of this distance together to get me the distance. Let me take another example of the same thing. Okay, so let me take another example. For example, this is your original position. This is a distance here, then a distance here, a distance here, here, and here. This is 2 meters. From here to here, this is 5 meters. This entire thing is 7 meters. So this makes it 2 meters here, because this will be 7 and this is a rectangle. So you start from here and you run all the way from here and then you come back here. I ask you your distance. Your distance would be 5 plus 2 plus 7 plus 2 plus 2. You will just simply add all of these distances and find out the value. This is 5 plus 2, 7, 7 plus 7, 14 is 14, and 4, 18 meters. So the distance is 18 meters. However, if I ask you the displacement, the displacement would simply be 0. Since this is your final position and this is your initial position, you haven't actually moved from your initial position. If you come to think about it, you are just there. So your displacement is 0 meters from your initial position. So displacement is measured from the initial position to the final position, and the direction is stated. So that is displacement.